Weak right now.
Column 3, trying to get zeros. We already set up our equations. We can't do the mental math.
Yeah!
All right, come on. I need you to turn done.
Those zeros.
Put in them zeros.
Put them in.
Here we go. We're getting row 1. We're getting row 1, yeah?
Yes.
We're multiplying all of these guys by -5/2 because it's the opposite. True?
Yeah.
Now, wait. We need to get that row. Hold on. So, what are we actually multiplying by? Are we multiplying this row by -5/2 because of that guy? Okay. So we multiply this whole row by -5/2 and we're adding it to the first row term by term. Nice thing is,
No, she did not want to come in.
I saw her first. I'm so confused.
all right, focus. Okay, now this is all in the video. You guys, your documentation of your squirrel moments. Okay.
Eric is
Ready?
like, what's going on over there?
Focus. 0 times -5/2 plus 1. 0 plus 1 is just 1. That's easy.
Oh, yeah.
0 times -5/2 plus 0. That's just 0. Oh, we already filled them in.
Yeah.
-5/2 times 1 plus 5/2. That's 0.
Zero.
Woo! -5/2 times 5/17.
I don't know if I like this halves thing.
Isn't that -25 34ths?
25 34ths.
Okay, so -25 34ths plus 3 halves. We need 3 halves to go to 34ths, which means times 17 over 17. So times 17 over 17, wouldn't that be 51 over 34?
Yes.
Ah, multiply 5/17 times -5/2.
We have 26 over 34.
So -25 34ths. And so then -25 and 51, we end up with 26, right?
Yes.
Oops, 34ths. I couldn't write. 26 34ths. Woo! Got it. Don't worry, we're almost done, right? Now what are we doing? Multiplying 5 times -5/2, that'd be -25 plus 31 halves. That's easier. Okay.
6 halves.
I'll ask you after. It's okay. Sorry, hold on. 5 times -5/2, -25 halves plus 31 halves would be -6 halves, right?
So -3.
No, that's positive. Positive 6 halves, positive 3. Double check, is that good?
Yes.
Okay. Row 2, we're multiplying row 3 by 3 halves and adding. The nice thing is
We got this.
times 0 plus, all those stay the same, which is why I have those two already done. Okay, now we gotta keep on going. What's 1 times 3 halves plus -3 halves? 0. What's 5/17 times 3 halves? 15 34ths. 5/17 times 3 halves, 15 34ths, minus 1 half, minus 17 34ths, right? Would be -2 34ths. 5 times 3 halves is 15 halves. 15 halves minus 19 halves, that's just -4 halves, which is -2. Good? Don't distrust me. Zero, 0. Now we're in 4th row. You guys double check my math, right? Okay, we're doing 11 halves times the 3rd row so that we can cancel stuff out. The nice thing is these ones stay the same, no big dealio. Now we have 11 halves times 1 minus 11 halves. The whole point, 0. Woo! 11 halves times 5/17 would be 55 34ths. Minus, we need 5 halves converted to,
Times 17.
which would be 85 34ths, right? Subtract, oh that's nice, -30 34ths. Wait, did that reduce? Go team. Divide everybody by 2.
15,
Yeah, -15 17ths, right? -15 17ths. Then last but not least, what do we got? We got 5 times 11 over 2, which would be 55 over 2. Wait, 55 over 2 minus 55 over 2 is, oh.
So Z is 0. So
Yep,
you
it's
think
coming.
you can put 0 for all the other ones? Because W is 0. Look.
No, I see what you mean. W is 0, it's then all 0. Well, hold on.
No, dang it.
Hold on.
Trying to make it short.
I know, but we're trying to finish. Okay. Column number 3 is
Done dealio.
dun. Column number 4, where do we start? We need to make who a 1? That guy. How do we, according to the system, make anybody a 1? Multiplied by the reciprocal. So negative 17 over 15 times row 4 into row 4. Making negative 15 17ths into a 1 for column number 4. Negative 17 15ths. Row 4 into row 4. You guys are hopefully recopying stuff. 1, 1, 2, 3. 0, 0. Unless something cancels out. Wait a minute. What didn't I do? What's negative 15 17ths times negative 17 15ths? Woo! There we go. Now what do I still need to make? I have my 0. I have to make the other one zeros, right? So we're going to multiply row 4 times the reciprocal. Now I know in this one Luke is already like, make them all zeros, but wait. Number 1, that's too big of a jump for some people. And number 2, I want to show you how even though these got really messy, they're about to get really nice. Because in order to get the top one to be 0, we're going to multiply the bottom one by negative 26 over 34, right? Row 4 plus row 1 into row 1. We can still do this with nasty coefficients. We're going to multiply row 4 by 2 over 34 to get rid of row 2's. We're going to multiply row 4 by 5 over 17 to get rid of row 3. I didn't put a negative, you're right. Thanks. Hell, it's got me. For row 1, the 1 stays, the 0s stay. All I have now is negative 2634 times 1 is negative 2634 is plus 2634. It's the whole point. That's 0. Now, why is Luca going on and on about 0? Because look, kiddos, when you multiply 0 by anything, what's it going to be? 0. And then when you add it to, what's it going to stay? 3. So guess what's going to go as we keep on going and as we go to multiply 1 by 2 over 34 minus 2 over 34, that's 0. And then multiply 0 by anything, still 0, it's going to stay the same. You can follow a similar line of logic and say, oh, hey, on this one, that one's going to become a 0 like it's supposed to. 5 is going to stay the same. So our final answer is x is 3, y is negative 2, z is 5, and w is 0. Whew. Dun, dun, dun. Is there a system? The answer is yes. Are we thankful for technology that can do repeated math very, very, very quickly? Yes. But did someone have to program it? Didn't take yours.
Man.
Someone had to program it.
That movie's good.
Someone had to learn how to program it. And there are quite a few jobs in the technology field, so some of you need to maybe learn how
This is only section 1.
to.
How many sections are there in this chapter?
This is the worst like mental math by hand of the entire chapter.
Oh,
Don't worry.
Okay. Because if this is a problem in the test, we need like a 3-day test.
3-day test?
Because this took.
Then I'll give you 3-day problems. I don't know if you want that. Hey, look, he was easy. There are more examples in this section? Okay, wait. Hold on.
Why would we need that? Why do we need her?
Why are you trying to kill us?
Hold on.
Who has the form decided?
Which one looks nicer, 71 or 80?
Personal finance.
Oh,
71.
although personal finance is very practical, and if you have a random spare spot after you take calculus, you can take personal finance. Okay, so number 80. I know, some of you. I know, it's okay. I'll still love you. The rest of you should. Okay, number 80. Question. Is something wrong?
Yes.
If you've tried to, wait, because a lot of you guys are like, I can do this in my calculator. If you try to do this in your calculator, what would your calculator say?
Error.
So it's impossible. No, the calculator can't be you.
Wow.
You can't be a calculator. Well, once upon a time people were computers, right? So many people. Yeah, exactly. However, you weren't meant to be a calculator, and the calculator's not meant to be you. Meaning, I need your logic for number 80. Kiddos, what do we do when we don't have enough equations?
Make a roll.
The passion.
We're smarter than a calculator.
But can you insert an alpha
Make
in
or yes.
the matrix?
Slave.
I wouldn't know what to do. So wait. Now, you could put this in a matrix, and it could simplify it some. It could get like some ones and zeros, but it couldn't go all the way because it doesn't have enough information. So it wouldn't be able to solve. Now, kiddos, hold on. How do we do this? Using matrices. Struggle. We do want C equals A, and I want you guys to still write that. I didn't mean to erase the entire thing. We do need that. So hold on. What would this matrix be when we made it? Once again, your calculator couldn't do RREF. Actually, it would try, and it would probably get to about where we are. But it would need us to make the jump to be able to make the final solution. Question. Start with the first column, right? Do we have a 1? Sweet. How are we going to get our 0? Yeah. Let's do -2 row 1 plus row 2. Into row 2. 1, 1, 1. Nope, too many. 4, 5. -2 plus 2, 0. -2 plus 1, -1. -8 minus 1, -9. -10 plus 9, -1. Double check. First column done. Second column. Get a leading coefficient of 1. Multiply by the reciprocal. Oh, hey, that's just -1. Row 2 into row 2. Top stays the same for right now. 0 times -1, 0. -1 times -1, -9 times, -1 times. Got it. Good? It's okay. Multiply the second row all by a negative. Multiply the second row all by a negative. Got it. Are we caught up? Oh. Sorry, the numbers are nicer. I can go fast with the nicer ones.
I see that we had in the second row -1, -1. You want to have 1 when we're looking across.
We wanted a +1, second column in the bottom. So we multiply the whole thing by a negative. Now, I need a 0 up top, yeah? How do I do a 0? Yeah. I take the row with my leading coefficient, multiply him by the opposite coefficient, which would be negative, add it to row 1, into row 1. Second row stays the same. My clues, I'm multiplying by a negative, so negative times 0 plus 1, still 1. Negative times 1 plus 1?
0.
0. So I have 1 and 0. Negative times 9 plus 4? Negative 5. Negative times 1 plus 5?
4.
4. Is that okay? Did I get my 0, 1? Yeah, I did. can't keep going. I can't go to column 3. So what do? Your calculator would get this far and say, uh-oh, I can't go any further. We say, all right, let's just take them. I have x minus 5z is equal to 4. I have y plus 9z is equal to 1. And I have z is equal to n. What are my final answers? What am I going to do? It's all dependent on z. Just plug in z. So trying to row reduce made it so all you have to do is instead of plug in z, find y, plug in y and z, find x. Just plug in z and then solve. So, x minus 5a, add 5a. X equals 5a plus 4. Y plus 9a is 1. Subtract 9a. 1 minus 9a. Z is equal to n. So row reducing even makes these types of problems nice because the back substitution is a whole lot easier than it was before. What did I do? I took z equals a into both of the upper equations. I plugged in a, not 9, sorry, 4z. What's the 9? I plug in a for z. So x minus 5a, add the 5a to the other side. Y plus 9a, subtract the 9a to the other side. So what do you think we're going to do on this one over here? Number 71. Wait, what's wrong with number 71? There's no z? What do we do if there's no z? How do we make that one possible? Number 80, we kind of think of the bottom row of 0, 0, 0, 0 to make it kind of work. What are we going to do for number 71? We could try to do elimination, like the first 2 and the second 2, and then put them all together. But since they gave us 3 equations, don't all 3 of them need to be true? Maybe the only way for all 3 of them to be true, maybe they're in a different plane or something. Maybe we need to add. Ready? Instead of adding an understood third row of 0, which led us to z, maybe we need to add in a column of 0. Does that make it square?
Yes.
There you go. So what do we do if there's not enough rows? Make a row of zeros, which ends up with z equals n. What do we do if there's not enough columns? Make an extra column of zeros. It's true. 0, 0, 0, 0, 0, z, 0, z, 0, z, but maybe we'll make the impossible possible. Does that kind of make sense, kiddos? Now I'm going to go ahead and zoom in on this matrix if it's okay with you. How do I start off? Making the negative 1, 1. Why? Because I need a leading coefficient of 1. So I'm going to multiply row 1 by negative, right? Negative 1 times negative, 1 times negative, 0 times negative, 22 times negative. Is that okay? Second row stays. Third row stays. Guess I got a little carried away. Got my leading coefficient. What am I going to do for my second 2? We're going to multiply row 1 by negative 3 to cancel that puppy out. We're going to multiply row 1 by negative. Yeah, we already did negative 3. We're also going to multiply by negative 4, yeah.
Okay.
Does that make sense?
Yeah.
Negative 4 row 1 plus row 3 into row 3. Row 1's golden. He has our leading coefficient. We'll leave him. Row 2. Negative 3 times 1 plus 3. Negative 3 times negative 1 plus 4 is positive 3. Positive 3 plus 4 is 7. Negative 3 times 0 plus, that's just 0, right? Negative 3 times 22 plus, is that negative 66 plus? Negative 66 plus 4 is?
Negative 62.
Negative 4 times 1 plus 4 is? 0. Negative 4 times negative 1 plus 8 is? 4 minus 8, and then that'd be negative 4. The negative 4 times 0 plus 0 is? What's happening to our 0, 0, 0? Negative 88 plus 32 would end up with 56. Is that good? Thanks. Negative 88 plus 32 is negative 56. Need to get a leading coefficient. We're going to multiply row 2 by? We have our first column. We want a 1 there, so we're going to multiply row 2 by 1/7, right? One-seventh of 7 is 1. 1/7 of 0 is 0. 1/7 of negative 62. You did that right? It wasn't negative 63. That would have been much more fun. Negative 66 plus 4 is negative 62. Oh well. Negative 62 over 7. Last one stays the same. Now what do? Get our zeros by multiplying by the opposite. So for row 1, I'm going to get, aren't they already opposite?
Is the
So you just do row 2 plus row 1 into row 1. For the bottom one, we need 4 times to cancel out the negative 4.
the
Yeah.
third row is wrong from the second matrix because it have negative 4 times negative 1 is 4 minus 4. No, the other one, next one. Where you're gonna plug in for row 3.
The equation is wrong?
No, because look, you put negative 4 row 1 plus row 3, right? You have negative 4 times negative 1, that's 4.
Oh, negative 4,
Minus 4,
sorry.
you should have a 0 instead of
You mean
negative
this one?
4. Yeah.
I did row 2, sorry, not row 1.
No, up.
Go up.
Can you go point in the board?
Yeah. 1/7 row 2. So this one. That
Right
one's
here,
wrong?
yeah. We have negative 4 times negative 1 is 4. 4 minus 4 should be 0.
No, because we're using the input.
You're using the.
Oh, you're on the wrong one. We're using the one
You're
before.
using- You're thinking ahead a step.
We go back. Does that make sense?
We're using the matrix above, and that's the output matrix that we get.
So like I didn't have this to begin with. Does that make sense?
Oh, so you just skip.
So when we solve, let me undo real quick. Okay. To get row 3, to get the new row 3, this equation says how to get from him to him.
Oh, okay.
So we have to look back and say negative 4 times the current row 1 plus row 3.
Oh, okay.
Is that back one? Yeah. So negative 4 times the current row 1, which was the before row 1. Negative 4 times 1 is negative 4 plus 4 is our 0. Negative 4 times negative 1 is positive 4 minus 8 is minus 4. Does that make sense?
Mm-hmm.
Negative 4 times 0 is 0 plus 0 is 0. And then negative 4 times 22 is negative 88 plus 32 is our negative 56. Is that okay? So remember, every time I'm writing that formula, I'm saying look back at the one before to build the one that's coming. Yeah, good question though. That's really easy to get mixed up. I've done that before. Now I'm building my zeros. Row 2 plus row 1, so 0 plus 1. Oh, wait, our second row stays. We can put that in. 0 plus 1 to do our first formula. 0 plus 1 is 1. 1 minus 1 is 0. 0 plus 0 is, look at that third row is kind of just a placeholder. Negative 62 sevenths plus 22. Negative 62 sevenths plus 22, we need to multiply by 7 over 7. Should be 154, right?
Yeah.
154 minus 62. 92?
Yeah.
Positive 92 sevenths, right? And last but not least, row 4. 4 times 1, nope, row 2, sorry. 4 times row 2, 0 plus 0 is still 0. 4 times 1 is 4, minus 4, 0. 4 times 0 plus 0 is just 0. 4 times negative 62 sevenths,
248. I got 248 cents.
good. Plus row 3, 7 sevenths, 392. Oops. 2 carry the 4, 35. 35 plus 4 is 39. Does that sound right? Oh my goodness, wait a minute, what? That's going to be negative 0 and then 3 and carry the 1, 637. Does anybody see a problem right about now? They're all over 7, but I see a bigger problem. That was 637.
Well, there's no diagonal ones.
When we go to do the third column, we know what x is, we know what y is, and we have a false statement. What? Can 0 equal negative 630 over 7? So will some of these be impossible? Because when you would go to write it, you would have x equals 92 sevenths, y equals negative 62 sevenths,
So
and
easy
z
to mess
equals nothing.
everything up. Look at the last one. 0 plus 0, 0 plus 0 plus 0.
Sum 3, let me help this way. Sum 3 can work, but here's a quick trick. The 3 will only work if one of these is equivalent to another. If one of these is equivalent to another, then the 3 might work. I guess there's another way all 3 could work. Because if you think about it, can all 3 intersect? And the answer is yes. Oops, well, if I had that guy in the right spot. 3 lines can intersect, that is possible. One way is if 2 of them are equivalent, 2 of the solutions are equivalent. But there's another way that all 3 can connect, but that would have to work out. So how it would work out at the very end is you would get, if it was to work, this would be 0, 0, 0, 0. True statement. But since it was a false statement, we know that it's impossible. All 3 of these do not intersect. If it was a true statement, you'd have all zeros, and then we'd say, sweet, x equals, y equals, and we're done. Does that make sense? Kind of, sort of, maybe. So if it was 0, 0, 0, 0, great, cool, x equals, y equals, and we're done. But since, does that make sense? Since the z wasn't there, the z wouldn't have been part of the solution, this would have been our solution, we would have to say no, because we had this little false statement going on. Yeah, because it could be a 0, 0, 0, 0, so it could have an actual solution of all 3. Now there are non-matrix ways of solving. But yeah. Now guys, the next few pages of notes are literally like, hey, if you want to check steps, like say you were doing a row reducing one and then you're like, oh, stink, I think I'm going wrong. You technically can do row reducing on your calculator, but oh my goodness, it takes so much longer because you have to type in each of the operations and have the calculator do it one at a time. So I did put in your notes if you're interested, if you get stuck on a problem and you can't figure out what your problem is, like in the sense of, that's not bad, you can't figure out what went wrong. You actually can do things like row swap if you want to change things around. You can do row operations. You can do multiplying rows by or adding rows together, etc. But it gets complicated. So I want to let you know it is possible to do row operations on your calculator, but I'm not sure if it's really that much better than just doing careful mental math with it. You could also check to see if things are equivalent. I still don't like that one so much. Instead, what I would point you to is what you already know. You can row echelon form, get it to be a stair step as much as possible. True statement, z equals a, solve. You can also do row reduced echelon form, which is the one that we prefer. But if you guys notice, why did I use these as examples? Wouldn't you still have to use your brain to say, z equals a, keep going? Okay, so even though you can use your calculator sometimes to check, doesn't mean it'll always get you to the final answer. There is one more example, but guys, I think we're doing all right. Do you think we're doing all right? I think we're doing all right. Let's go ahead and just start 8.2. Just so that we can see that not all of chapter 8 is row reducing. Pretty much it was just 8.1. The rest of chapter 8 is just more matrixy stuff. Now, if you have an even in section 8.1 that you're trying to row reduce and you get kind of stuck, could you throw it in your calculator, use RREF, see what the right answer should be to be able to compare? Yeah, definitely. I'm not saying you can't touch your calculator, I'm just saying try to get there by hand. But check with your calculator, totally fine. Quick reminder, A sub n by n. We're talking about entries. Remember, the row comes first, the column comes second. If two matrices are equal, that means their terms have to be the same. Okay. Not like vectors. We can't like move it all over the place and have different numbers equal. The entries have to be the exact same. So if you see two matrices that are equal, the nice thing is, if you're missing this spot, well, it's going to be a 2. If you're missing that spot, it's going to have to be the -3, etc., etc., etc. They can make this much more exciting. They can make this much more exciting. But in order for two matrices to be equal, the elements must be equal, the entries must be equal. However, if they start multiplying an entire matrix by a scalar, by 1/2 or by 2, it might look different, but the value has to overall be the same. Yes, that's corrections. What did he do? Who's going to be gone tomorrow? AP Bio, AP Chem? Oh, well, anybody? Jazz going to AP Bio, AP Chem? Just. You guys know where to find stuff. Online, notes, videos.
I know, only on test days.
So how would you solve? How would you? Yeah, corresponding something, right? Oh, that's not bad. That's not bad. 2x plus 1 equals 5. 3x equals 6. 3y minus 5 equals 4. X equals 2. Y equals 3. X equals 2. Woo! What would have happened if these were different? Would it have been a possible solution? What if those had been different? Wouldn't that be a breakdown? We have to say, oh, no possible solution. Does that make sense? And that's what happened in the last problem that we did when we had that false statement at the end. It's like the information doesn't match, and then we were in trouble. Although technically we're not solving for a point, we're just solving for unknowns. So we'll say x equals y equals. So that kind of problem's not too bad, as long as you just realize, oh, they have to correspond, otherwise we're in trouble. Does that make sense? Couple more seconds. Yeah.
The axis doesn't matter.
Then the constant. Yeah. We say no solution. And I was drawing the comparison to that example that we just got with 0, 0, 0, negative 637. So it was like, oh wait, somehow the three givens don't match. They weren't able to go up together. Okay.
If you got two different answers for x, is it inconsistent or is just two other points?
You would say inconsistent and say no solution. But in this case, since technically it's not like a system representing lines, we would just say no solution because we're not specifically talking about. Does that make sense?
Mm-hmm.
We're not specifically talking about graphs. So 2x plus 1 is in the 5 spot, 3x was in the 6 spot, 3y minus 5 is in the 4 spot. Alright, so that's not bad, right guys? Maybe 8.2, nothing to be scared of? What else is coming? Oh no! We're gonna see matrix addition! Oh wait, just kidding.
I complained about chapter 5.
Wait, but look at number 1. How easy is that? Would you guys have found the answer?
Yeah.
Yeah, you could. That's
That's like the only technically, that's like.
Yay! Okay. How about number 2?
Let's make our own row. Our own row three.
Make our own row of zeros.
Yeah, make our own row zeros.
What am I gonna say?
Red.
What does the directions at the top say?
Corresponding entries. Same order.
They're not the same order. We can't add or subtract. Question.
This is such a bad
Woo!
move.
Is it gonna get fun?
That's easy.
How do you do that?
Distribute.
Distribute the 3 to every single entry, guys. Me too. It's gonna be nice.
Yeah,
one tonight.
Okay.
Get through 8-1 tonight. We'll take questions tomorrow. 8-2 week 1 5.
Oh, that's a bell.
Too much talking.
One is a good row.